Hey everyone, my name is Wael, and today I'm going to show you how to set up Evilginx with browser in the browser in a completely new way that bypasses any known security measures that are implemented by famous websites like Microsoft and Google. Now, for those who don't know, browser in the browser was a concept introduced by Mr. Docs quite some time ago, where basically we show the user a fake browser window that appears to be a normal interactive one, but inside of it you can place your own content. And in the case with Evilginx in previous years and months, you could basically put the proxied website, the proxied login page inside that fake browser window, and you would have a very deceiving and very convincing phishing campaign. The problem nowadays is that if you try that, you will end up with two problems. One of the two problems, either the proxied content is not going to play at all inside the iframe, or it will play at the beginning, but then once you go to the password screen or the multi-factor screen, then you will have a redirect that changes the whole page and breaks the whole effect of browser in the browser. This is something called frame busting technologies that are implemented by popular websites right now. There are various techniques that are used, mainly JavaScript based, where they either detect the presence of an iframe if they're being placed inside an iframe, or they even attempt basically to force a redirect outside of the iframe, meaning your whole page is going to be redirected to the next screen, and that results in the whole thing being gone. I'm going to show you a concept that introduced a few months ago. If you haven't seen my presentation at BSides, please take a look. I explain concepts more than just like in the browser. I show you how to bypass spam filters, how to bypass detections, how to perform some interesting techniques that will make your phishing campaign highly more effective. Before we begin, just a reminder, please use this in a legal way on targets that you have complete authorization to test your phishing campaigns against. One more thing that I'm going to show here, the setup that I'm going to show you today is going to be on a local VM, and the reason being basically the browser is heavily detected and punished if you don't implement enough obfuscation and bypass techniques. Then you're likely to burn your domain, and I don't want you to burn your domains while playing with this. So I'm going to show you how to set it up locally, but in such a way that you can replicate the exact same thing on a live server with your own domain. Without further ado, let's jump straight into it and let's take a look at how you can actually set it up and what are the concepts behind this new browser in the browser technique. Right, so to get started, we're going to need our virtual machine. I'm using Ubuntu 22 on VMware Workstation on Windows and Parallels Desktop on Mac, but feel free to choose anything else that you're more comfortable with. All right, so let's get started. Now, I'm going to assume that you've already set up Evilginx on your Ubuntu machine and that you've cloned the repo that I linked in the description below. If you don't know how to set up Evilginx, I recommend that you take a look at the documentation or try the course by the creator of Evilginx, by Kuba, or follow basically the instructions, the step-by-step instructions that they included in the README of the repo. I also explain like a few other things, how to set up, your firewall, how to troubleshoot a few errors, but that's going to be a little bit out of scope for this video. Now, once you've run Evilginx at least once on your machine just to test that everything is working, there is a file called config.json that's going to be created. So we're going to go ahead and start by changing that. Now, the first time that you run it, by default, you will see the HTTPS port for set to 443. We're going to change that to something else. Let's go with 8443. The reason is that we're going to add Apache in front of Evilginx, and we need Apache to use the 443, the HTTPS port, and then forward things on demand to Evilginx. So let's go ahead and save this, exit, and let's go back to the repo, to the folder of the repo that we cloned. Now, here we have basically, the first thing that we're going to take a look at is basically the setting up Apache. So let's go ahead and install Apache. I've already done that, so you see it didn't take time. And let's enable a few Apache mods that are going to be used. They're mainly used to handle, proxying the traffic towards to Evilginx, handling, things like the substitutions that we're going to talk about later, which actually create the whole effect, and caching and stuff like that. So let's go ahead, enable them. Let's start Apache, and let's enable Apache as well. Right, so now let me clear the screen. So if you see here, we have a folder called, a directory called pages. If we see what's under pages, we see 3 directories: home, primary, and secondary. Now, those are basically directories that include HTML, CSS, and JavaScript that are going to be used for different pages and different stages of our setup. Home is going to be the home page that the user sees when they visit the base domain. In our example, we're going to set up everything with fake.com. And when the user visits fake.com, they're going to see something that looks convincing as a homepage to increase our chances of not being detected and, basically make it more believable. The primary is basically the landing page. So whenever the user visits the lure from Evilginx that we generated, they're going to see, I'm using the same example that I used in the BSides presentation. What the user is going to see is basically a calendar widget from Calendly behind what appears to be as a paywall. And it asks the user to first click on a button to log in with their Microsoft account. That button basically will open our fake browser. Once they log in, we enable the Calendly widget so they can interact with it and select the date and time. We're going to go through everything in a moment. Let's first go ahead and create the directories for all of those pages. So we have here, we're going to create 3 directories under var www, which is going to be used by Apache. Let's go ahead and create home, create primary and secondary. And let's go ahead and copy the contents. I'm going to fix a few commands here that you see me editing on the fly. It's just a few things that I left behind. Right, let's copy the last one. All right, so now if we try to see what's under var www, we see all 3. Let's remove also the default one that comes with Apache, the HTML. So we don't have any conflicts with what we have. So now if we list again, we have the 3 directories that we want. Now, the next step that we're going to do is basically generate the SSL certificates. So in a live server deployment, what you're going to do is basically either rely on Evilginx. Evilginx 3 handles SSL certificates based on the subdomains used by your fishlets. Personally, I prefer to avoid letting Evilginx handle the certificates just because it might trigger a few more warnings and it might help detect our domain and flag it. What I usually use is basically I generate a wildcard certificate for all the subdomains that we might need, and then do that once, then instruct Evilginx to use those certificates. In our example, since we're setting things locally, we're gonna generate self-signed certificates for the domain fake.com, and then we're gonna make our host machine trust those certificates so we can play basically locally with the fake.com domain to make it more realistic. Now, I created basically a directory for the fake.com certificates, and then we're going to use this command to generate the certificate basically that we're going to be using. Now, the repo comes with an OpenSSL configuration file, which basically tells it to generate certificates for fake.com and wildcard.fake.com. Now, if we go ahead and generate the certificates, go back to the instructions, let's change the permission of the private key so we don't have errors down the line. And now we have the SSL certificates generated, ready on our machine. The next step is that we need to take a look basically at the actual configuration of Apache. So under custom subs, I have 2 files here, winchrome.conf and macchrome.conf. Now, if we take a look at what they look like, you can see it's a sub configuration file for Apache, which basically just replaces a few things on the fly. So we replace the body tag with a custom body tag. We inject things at the beginning of the HTML body. We inject a few scripts and a few style sheets, CSS style sheets that we have here. Now, in the repo, you're going to see basically at the moment of this recording, you're going to see two files, one called mac.chrome.conf and one win.chrome.conf. I tried to keep things simple, and basically I included two examples, one which is a fake Chrome browser on a Windows machine, another one on a Mac machine. The CSS files handle basically the difference between dark mode and light mode based on the system preference, but I tried to keep it simple just so you can understand exactly what's going on. Another thing is that you probably, once you understand, once we explain later what's exactly happening, you're going to want to obfuscate the HTML here and play basically with a few more tricks to avoid detection. I kept things simple just so you can actually understand what's going on exactly based on the concepts that we're introducing. Now, let's go ahead and copy the folder of the custom subs to etc Apache 2, which is going to be used by Apache. The second thing that we have here is you have two files under Apache configs. So if we check Apache configs, we have two files again. They're exactly the same, with the only difference is that there is a line commented out. Here, this lines, basically these two lines change, enabling basically the Windows Chrome version or the Mac Chrome version. Now, you can take this a step further and have automatic detection based on the user agent, but let's keep this simple for now. Now, let's go ahead and copy the Windows one, since I'm on Windows right now. So we're going to copy it, and basically it's going to replace the default configuration of Apache, which is under etc Apache 2 sites enabled, and it's usually named 30-default.conf. So we're going to replace it with ours. And then we're going to run a config test on Apache to check that everything's correct. We don't care about the warnings for now. Syntax is okay, so we're good to go. Let's restart Apache for the changes to take effect. Right, my computer is freezing a little bit. Right, so my VM froze and had to restart it, but we're good to continue from where we left. Let's go ahead and run the config test once more, just to make sure that we don't have any problems. We see the syntax is okay, so we're good to go. Now let's restart Apache for the changes to take effect. And now, since we don't own fake.com, and it's basically the domain that we're using for the whole setup locally, what we need to do is basically modify the hosts of the Windows machine. So what we're going to do basically is point fake.com to the IP of this virtual machine. Now, I explained in the repo how to do it on both Windows and Mac, but since I'm on Windows right now, I'm going to show you how to do it on Windows. So the first thing that we need to do is open Notepad as administrator. I'm not going to click this now because for some reason it breaks my recording, but I already have it open here as administrator. The next thing is that we're going to copy from the repo this location here, which is basically Windows System 32 drivers, etc hosts. So let's click on File, Open, and then let's paste this one. Let's remove the hosts from the side. And we changed from the file types from text documents to all files. And now we can see this file here called hosts. If we double click it, we can see this entry here. Now what we're going to do, I've already prepared basically the different subdomains and the base domain that we're going to need to point to our VM. But Evilginx, at least Evilginx 3, has a built-in command called, I think, fishlets get hosts, which is going to give you all the subdomains that you would need to use basically for the setup. So let's copy this. Let's go at the bottom of the file, paste the entries. Now we still need to replace basically this placeholder here with the IP of the VM. So let's run ifconfig. Let's grab the IP of this device and let's go back to our notepad. Let's search and replace for all the entries of this placeholder. Replace all. And now we can see basically that all of the, basically the base domain and the subdomains that are used for the Microsoft Fishlet, all of them will point towards this IP. Hit Control S to save. Let's get rid of this for now. And let's open our browser. So now if we visit https://fake.com, we are going to get this warning, which is normal because we used self-signed certificates, which are not signed by a trusted authority. So if you click Advanced just to proceed here and see if everything is working, let me refresh this. So we see the home page that we configured on Apache. So this means the setup is working, at least for now, but we need to trust the certificates to avoid any errors. So we're going to click on the not secure icon. Maybe you'll see it as a different icon here, depending on the browser that you're using. But on Chrome, let's click on certificate is not valid, details, export, and then let's keep the name as it is. We don't really care about that, but we need to add .crt for Windows to actually pick it up correctly. Let's click enter. I'm going to replace it. I already had one, and let's go find it in the downloads folder. So if we double click on it right now, install certificate, current user, place all certificates in the following store. So we're going to choose manually to place it under trusted root certification authorities. Click OK, next, finish. Ignore this warning, the import was successful. So this means basically that now if we close our browser and open it again and go back to https://fake.com, we can see that we got rid of the untrusted certificates warning. Now, let's go back to our VM and let's go to our Evilginx directory. I think I placed it here, all right. So now we're going to run Evilginx in developer mode. So we're going to add -developer. And this is mainly to avoid Evilginx basically requesting SSL certificates automatically, which we're not going to need in this setup since we've done everything with our own certificates. So let's click enter. Everything is starting up. We see the fishlet. The fishlet name is 0365. I've included it in the repo. It's for the enterprise version of Microsoft accounts. Let's go ahead and configure the basics of our Evilginx. By the way, you could run, in the live server, you would run Evilginx in a session manager like Tmux maybe. That's the personal one that I use, just to avoid basically the Evilginx session being lost if the server restarts or if you lose basically the SSH session that you already have with the live server. But let's go ahead, let's config the domain, config domain fake.com, config IPv4, and we're going to set this to localhost since everything is going to be basically behind our Apache server. And now so one more thing, we need to change the blacklist mode to no ad. And this is basically because Evilginx by default, it tries, if you leave the blacklist on, what will happen is that when anyone requests a URL other than the lure URL, they're going to be added to the blacklist, assuming that there are scanners or detection engines and stuff like that, or somebody investigating. But in our case, since Evilginx is sitting behind Apache, it's going to see all the requests coming from the localhost IP. So we're going to change the blacklist mode to no ad, and now we're ready to set up the fishlets. So let's go with fishlets. Let's see what we have here. So fishlets, host name, and then we're going to set that to fake.com. Which is the base domain that we're going to be using. I forgot the name of the fishlet. So fake.com, fishlets, enable 0365. And now let's create the lures. Let's check that we don't have anything running. So lures, create 0365. Now, if we see the lures, we have this one here. Let's clear the screen. So we have our lure here. Let's grab the URL. So get URL. Right, so now that we have the lure URL, let's go to our browser. I'm going to open a guest window. And let's visit the URL. So now we see this Calendly widget that's disabled. We can't interact with it. and it's asking us first basically to sign in with our Microsoft account. Once we click this, we have the fake browser window. We see it's fully interactive. It expands, it collapses. We have some extra things here to make it more believable. But let's go ahead and enter our email, then the password. I'm going to go to my phone and enter the multi-factor code. Click yes. And now we have the fully interactive widget from Calendly. We can click schedule an event. You could use JavaScript here to pre-fill the name in the email if you have it. This way you make it more believable. The goal is basically to make it as less suspicious as possible, not only to phish the user, but also to not trigger any warnings or make them basically suspicious that they've been phished. Now, let's go back to our Evilginx server. Let's test that the session captured basically works. I'm going to copy the captured cookies. Go to my browser, to this window this time. Let's go to login.microsoft.com. We see that we're asked to log in. Instead, what we're going to do is basically delete all the cookies using the edit this cookie extension, paste what we got from Evilginx, hit yes, and hit refresh. And now we can actually see that we're logged in as the user. So everything works properly. We have the home page, we have a convincing landing page, we have an interactive browser-in-the-browser attack with Evilginx bypassing the most advanced security measures against browser-in-the-browser that exist right now. Right, so let's take a look at how this works and why it works. So first, let's see the original page from Microsoft that we're proxying basically through Evilginx. Let's take a look at the HTML. So the HTML basically inside the body tag, so you have the head tag with a bunch of scripts that are loaded, style sheets and JavaScript files mainly. And then you have basically inside the body that has specific classes, specific basically data binds. So Microsoft basically is heavy on detecting and breaking the flow if you modify anything from their original content. So if we take a look here, we can actually inspect and see the smallest element basically that we can grab to place it inside the fake browser window. We don't really care about the outer part, which is a background. It might even break things for us. So let's grab this one here. So we see it's a div with a class when scroll. Now inside this is all the logic, all the relevant HTML. But what happens is that if we try the typical approach of placing basically an HTML wrapper around this and then modify it with our own CSS, what will happen is that it will break the whole flow of Microsoft. So instead, what we do is basically let's go to our landing page and see what's the difference. So we see again the data binds, the original two divs that we've seen in the original one. Let me just close things so you can see it. So yeah, so we have here basically the two or three divs basically that we have originally here. And what we're doing, we're actually adding a few more at the beginning of the body tag. So instead of placing the Microsoft content inside of our own HTML, we're just placing our own HTML besides it. So it's just like, on the side, not affecting the flow, not affecting, the structure of the original content that they have here, but it still adds our own HTML content. Now, let's start from the pop window. So the pop window is basically the actual the actual browser-in-the-browser effect that we're adding. It's purely based on CSS. The whole logic of basically showing it at this specific location. We use top, left, and transform options in CSS. And with JavaScript, basically, we grab the position when being dragged and dropped. And as you can see here, the values are changing of the top and left. Now, we add another container behind this. So if I go and change the display here to none, just so we don't see it. So now that I remove the browser-in-the-browser effect, we see that we have also a container that's identical, but with a white background. This is mainly because everything around this element from Microsoft that we grabbed is transparent, and we need to make sure that we are always, showing something solid behind it. Not really important, but just giving you the whole explanation of how things work. Now, this is basically the creation of the browser in the browser. Let's go and take a look at how we actually achieve that. So first of all, in the main file of patch configurations, we're simply basically specifying a bunch of configurations just to be able to serve the content of primary and secondary under their specific paths. And then we're proxying everything to the port that Evilginx is listening on. And the next two steps, basically, we're just enabling the substitution that we're going to show in a moment. And then we're just excluding basically all the effects of replacing content are not going to take effect on secondary and primary, because otherwise we'd end up in a loop, would be basically replacing again and again and again the same thing, since the content that's being replaced with is from secondary and primary. I added this extra step here. It might not be really needed. It's just basically to differentiate between, the basically no path and the specific path with the auth2, which is usually used when you try to log into Microsoft. Inside those, we basically include the second file, nothing special here. We have an extra step here for caching. So the caching effect will help us, as you will see in a moment, between the redirects, instead of actually calculating and, sending everything from the beginning, we're just caching everything. So the effect, there's no flashing effect basically between the redirects. Because every time we're actually injecting, again, the same HTML content with JavaScript and CSS and everything else between each redirect. We also have a separate virtual host here just to be able to handle the base domain on its own. So when we go to fake.com, not something.fake.com, we end up with this landing page here. Now, let's go into the file that we're including here, which is basically the substitution file. So this file is basically a simple search and replace. We replace the closing head tag with basically two scripts that we inject, one which is our script and the other one which is Ajax. This might not be really needed, but I kept it for now since I'm using jQuery in the current setup. But the important thing is here, basically, we're actually replacing the body tag. If we go back to the original one that we have here, we see that the body tag has data binds, classes, and stuff like that. We replace it with exactly the same. We don't touch that. We simply add on the side our own HTML content. So we see here this div primary, pop background container, and pop window. Those are the three main things that we're injecting in terms of HTML. And then in the head tag, we're actually injecting our own CSS and JavaScript for the functionality to work. Now, the rest of the stuff here is very simple. It's basically just the structure for the actual pop window, the browser window, placing buttons, placing, the text and stuff like that, and handling most of this with CSS. Now, I added one more thing for demo purposes. So if you see here the text of the login.microsoft or the URL here and a few other things, they're not exactly the original text. They're slightly obfuscated, nothing special. I kept it simple just so you can understand what's going on, and just to show you that you could eventually wrap more than this. Basically, you could obfuscate the whole HTML content that we're injecting to make it even more convenient, even more stealthy in terms of scanners and detection and stuff like that. There are more details in the README file. I'm going to explain step by step, what's happening exactly, but this is out of scope for now. But let's go and see the interesting parts, which is CSS. So the whole magic is happening using CSS. So how did we place this inside this with the whole effect basically taking place? We're grabbing that WinScroll element that we've seen before. So this one here. So we're grabbing this element here. We're basically setting a Z index just to place it above our own CSS and HTML that we're injecting. And then we're applying the same positioning using JavaScript for all of them. So all of the three elements, the background container, the white background container behind this piece here, which is the browser window, and the wind scroll element from Microsoft, which is the original one, we're all applying to them basically the same width, height, and positioning, basically left to top, and and a few other things here. We have some extra JavaScript just to set the initial size. So by default, it will come to this initial size. But there's extra things basically that are going on here. So if you click expand and you hit refresh, you're gonna come back to the expanded version of it. The position is the same. So if I place it here and hit refresh, it should go back to the same positioning. So we make it more believable between the redirects, because remember that the sign in with Microsoft here, once you enter the email and the password, the multi-factor screen is a completely different page than the original one. So we need to keep that persistent. Nothing special here. We simply store everything in the local storage. If we go here, we can see basically we're storing the positioning and a few other things. If it's open, if it was open or not between the redirects. If you close it and hit refresh, you will still see it closed. I don't think there is much point basically going through the exact JavaScript code that's going on here. One important thing is basically how do we set up the background. So this landing page background is basically what could be a little bit tough. In the initial version that I tried, I used an iframe. So I placed an iframe to hold the content from the / primary, basically that landing page that we added, just to host it inside an iframe, and simply basically set it up here inside the replacement. So we'd replace primary with an iframe. But since we want a completely basically frameless approach to this browser and the browser attack, what I did is basically I used another trick, HTML trick, which is called shadow root. So what's happening here is that inside the JavaScript file, if we go to the end of it, we can see that we're injecting further HTML inside the primary, but we're not injecting it directly inside the HTML. So we're creating what we call shadow root. Shadow root is some kind of isolation, let's say, that prevents the CSS that you inject inside of it from interfering with the outside, with the rest of the content of the original Microsoft page, and vice versa. And the same applies to JavaScript. Now, since we still need some interactivity between the two, what we use is basically custom events. So both the script from primary, so the landing page that we have behind, and the script of the browser and the browser, they both use custom events that get sent, and basically they escape this, in quotes, sandboxing technique of shadow root to be able to interact and inform basically the parent page that, hey, now the flow is complete, so now you can actually enable the calendar widget, or the button was clicked, so trigger the opening of the browser in the browser window. That's mainly it. I think we've covered basically the basics, at least, of how this works. You can take a look. I would suggest that you take a look at the code and the README file. You would understand a little bit better why this works and why this is not. It's not easy to prevent it basically with typical frame busting techniques. We're basically ditching the whole concept of iframes. We're just playing with CSS tricks and a simple search and replace in Apache to do the job. So one more thing, in this public repo, I included most of the concepts that are used basically to create this browser in the browser. It's enough to actually, get you started, and, maybe you could customize it further depending on your needs. Maybe you could integrate it with other websites as well, besides Microsoft. The only thing that you would have to change is mainly basically playing a little bit with the CSS selectors based on the website that you're targeting. But I'm planning to, if there's enough demand, I'm planning to release a toolkit, a really powerful toolkit that will include this concept on steroids. It's going to include heavy obfuscation, heavy encryption, bypassing detections, bypassing scanners, maybe custom blacklists as well. Some, kung fu, JavaScript, basically techniques, just to make sure that you're always going to have a very deceiving and very convincing phishing attack. If you're interested, please let me know in the comments below or hit me up on LinkedIn. I might include at some point a waiting list, so keep an eye out. I'm not sure yet if it's going to be a paid version, a free version. It really depends on on the demand and what's going to happen by then. But please let me know what you think. If you face any issues with this setup, either create an issue on GitHub or comment below under the video. And see you next time.